students, so we have discussed all about thermodynamics, what were the different laws, what were the different processes, and what are the applications of thermodynamics. Once we had the discussion of all the complete theory part of the chapter, it's the best time that we should start solving certain previous year IIT-JEE questions. So in today's class, I'll try to discuss 5-6 different questions of IIT-JEE. All these questions I have tried to take up from the previous year examinations. Moreover, all these 5 questions, they have been taken from different parts of the chapter, so that you can get the confidence of all the parts of the chapter. Let's begin up with the today's session. Now students, having discussed about the chapter thermodynamics, it's the best time when we should start doing the practice for the questions which have been asked in previous year IIT-JEE. Now if we do such questions, these questions will genuinely help us out in the upcoming exams. So let me start with the first question which I have chosen to teach you people. The first question that has been asked to us is, when 2 grams of a gas are introduced in an evacuated flask kept at 25 degrees Celsius. That means I have a flask with a temperature as 298 Kelvin and I have taken a gas where the mass of the gas which is kept inside is 2 grams. So this has been introduced into an evacuated flask which is kept at 25 degrees Celsius. The pressure is found to be 1 atm. So in this case, the pressure has been found to be 1 atm. Now if 3 grams of another gas is added to the same flask, now I am adding 3 grams of another gas which is added to the same flask, the pressure becomes, so the final pressure becomes 1.5 atm. Now we have to tell him the ratio of the molecular weights of these 2 gases will be. So we have a gas 1 and we also have a gas 2, and we need to basically tell him what is the molecular weight, the ratio of the molecular weight of these 2 gases. So how am I going to do this question over here is using the very simple concept that pressure will be directly proportional to N, because we know that PV is equal to nRT. If the temperature of the gas is kept constant, R we know. If the volume is same, we know that the pressure is directly proportional to the number of moles. Now if pressure is directly proportional to number of moles, and number of moles can be written as given mass by molar mass. So I can very easily say that N1 is equal to 2 by M1. Moreover, on the similar lines, I can also say that N2 is equal to 3 by M2. Now I know N1, I know N2. I can also write that P1 by P2 is equal to N1 by N1 plus N2. So this is the first equation that I have written. So I can say N1 plus N2 will be equal to 1.5 times N1. Since putting all these values, I have obtained these 2 equations. So I can say N2 will be N1 by 2. Now once I have arrived at this point that N2 is N1 by 2, I can very easily put these values in the above 2 equations. And if I put these values in the above 2 equations, I will get 3 by M2 is equal to 2 by 2 times M1. Now you can take the M1 and M2 on left hand side. So you will say M1 by M2 comes out to be 2 by 2 into 3, which comes out to be 1 by 3. Let me see if any answer is given as 1 by, the first option is given as 1:3. So we can say A is the correct option for this question. So students, we can deal such kind of questions in the terms of simple equation of normal PV is equal to nRT. Now if I move over to the second question, the second question says a monoatomic ideal gas which is initially given at temperature T1. That means I have been given a gas which is monoatomic, and it was initially given as temperature T1. This is enclosed in a cylinder which is fitted with a frictionless piston. So you have a cylindrical arrangement which is fitted with a piston arrangement. Now this gas is allowed to expand adiabatically. So I am adiabatically trying to expand the gas. Now since I am trying to expand the gas, the temperature changes to T2 by releasing the piston suddenly. Now he says if L1 and L2 are the length of the gas column before and after the expansion respectively, then you need to tell him the T1 by T2 is basically given by. That means I have to simply try to correlate the value of temperature T1 by T2 to the length of the container. Now, to do this type of question, since it has been given, the process is adiabatic in nature. If the process is adiabatic in nature, I can very easily write Tv gamma minus 1 is equal to constant. Now, since the gas which is given to me is a monoatomic gas, so the gamma value can be taken as 5 by 3, and hence I can say that Tv 5 by 3 minus 1, which is equal to T into V 5 minus 3 by 3, that is Tv into 2 by 3 will be a constant value. Now, since I have got an equation, I can very easily say that the volume will be given as what? I can simply write T1 into L1 raised to the power 2 by 3 will be equal to T2 into L2 raised to the power 2 by 3. And why this is so? Because the volume is directly proportional to length. Since it is a cylindrical piston that has been given to me, so I can very easily say volume is directly proportional to length. So I can replace the terms of volume in the terms of length. Now, taking these two things into consideration, I can say T1 by T2 will be equal to L2 by L1 raised to the power 2 by 3. Let's see if we have any answer. So we have L1 by L2 raised to the power 2 by 3 and L2 by L1 raised to the power 2 by 3. And the answer we have obtained is L2 by L1 raised to the power 2 by 3. So I can say D option is the correct option. Having done this question number 2, it's a time that we should come over to question number 3. In question number 3, we have been said that in a given process on an ideal gas, dW will be equal to 0 and dQ has been given to be less than 0. Then the gas, okay, so now he has talked in the terms of the temperature will decrease, the volume will increase, the pressure will remain constant or the temperature will increase. Let me take into all the options one by one. Since it is an ideal gas, using the first law of thermodynamics, I can write du is equal to dq plus dw. This is what is given by first law of thermodynamics, that the total internal energy is equal to the change in work done plus the change in heat change. So, it has been given to me that dW is equal to 0. So, I can say du is equal to dq plus dw. Since dW has been given to me equal to 0, I can say du is equal to dq. Now, I have also been given that dq is less than 0. That means the term dq is negative. If dq is negative, I can say that du also comes out to be negative. So, if du is negative, that means the internal energy is decreasing. Now we have done, since the gas is an ideal gas, and for ideal gas the internal energy is a function of temperature only. So if there is a decrease in internal energy because du is given to be negative, I can say the temperature is also decreasing. Let's see the options once again. Oh, the first option says the temperature will decrease, and hence this is the answer. Having done question number 3rd also, now it's a time that we should move over to question number 4th. The question number 4th says, a cubical box of side 1 meter contains helium gas. That means you have a cubical box, the side is given to be 1 meter and the helium gas is contained in it. The atomic weight is given to be 4. The pressure is given to be 100 Newton per meter square. During an observation time of 1 second, that means the experiment was conducted for 1 second, an atom travelling with the root mean square speed parallel to one of the edges of the cube, that means a cube which was given to you, an atom is considered which is travelling with root mean square velocity and it is travelling parallel to one of the edge of the cube. It was found to make 500 hits with a particular wall. So I suppose I am choosing the right hand side wall, and if I am considering an atom coming from left hand side, so it was found to have 500 hits without any collision with the other atom. So it's not colliding with the other atom and it is simply going and striking the wall. Now he has given that take R is equal to 25 by 3 joule per mole and K is equal to 1.38 into 10 raised to the power minus 23 joules per Kelvin. He has asked us to evaluate the temperature of the gas, the first thing. He has asked us to evaluate the kinetic energy per atom, and he has asked us to evaluate the total mass of the helium gas in the box. So, using all the data points that has been given to me, I can very simply say that the distance that will be traveled by one atom of helium. Now see, the time is given to be, so there are 500 hits and the 500 hits are taking place in 1 second. So I can say that if I am talking about 1 by 500 of any second, that means that now in 1 by 500 seconds, I can say that the time between two successive collisions is 2 meters. So this is all what I have looked at the data points, and I collected the information that the time between two successive collisions is 2 meters. So if I am asked to find out the root mean square velocity, I can very easily write C RMS is equal to distance divided by time. Since I am finding out the speed, so I need to use the formula distance by time. Now I know distance is 2 meters and I know time is 1 by 500. So the distance comes out to be, so the speed comes out to be 100 meter per second. Now using this value, let us calculate what has to be calculated in part number 1. The part number 1 says the C RMS. I can also write the C RMS is equal to root 3 RT by M. I know the value of C RMS, so I can put it over here and I'll simply say under root 3, R has been given to me as 25 by 3. I don't know what is the temperature, so I can write T. Mass of helium is given to me as 4 into 10 raised to the minus 3. So if I put down the values, I will get T is equal to 160 Kelvin. So if I can put out the value, so we have 2 by 1 into 500, so this comes out to be 1000 meter per second. And I need to equate it equal to 1000 meter per second. So on putting the values from equation number 1 to equation number 2, I can get the value of temperature as 160 Kelvin. Now since we are done with part number A, let us move over to part number B. He asks us to find what is the average kinetic energy of an atom of the monoatomic gas, and by the formula we know that the average kinetic energy of an atom is 3 by 2 kBT, where kB is the Boltzmann constant that has been given to us. So I can calculate E average as 3 by 2 kBT. So I can put up the values 3 by 2 into 1.38 into 10 raised to the power minus 23 into 160 Kelvin, since the temperature kB values is given to me, and the value will come out to be 3.312 into 10 raised to the power minus 21 joules. So we are done with part number B also. Coming over to part number C, where we have been asked to calculate, now let's see, he has asked us to calculate the total mass of the helium gas inside the box. We don't know what was the total mass of the gas which is present inside the box. So we are asked to calculate that total mass. I can very easily say from the equation PV is equal to nRT. I can say PV is equal to given mass by molar mass into R into T. Now I know what is, so I can calculate molar mass will be P into V into M divided by R into T. We know what is pressure volume, molar mass, we know R, we know T. So if you put down all the values looking into the equation, you will calculate the mass given to us is 0.3012 grams. So this is up to 4 places of decimal. You can also give the answer up to 2 places of decimals. So this was a kind of theoretical question, but that has been asked in JEE, so I tried to discuss this question with you people. Now, since we are done with this, let us move over to the last question, where the question number 5 is considered. So he says, a Carnot engine whose efficiency is 40% takes in heat from a source which is maintained at a temperature of 500 Kelvin. It is desired to have an engine of efficiency 60%. Then the intake temperature for the same exhaust, the same sink, the temperature must be. So this is very simple question. The question is entirely related to the concept of Carnot engine. Now let us try to solve this question using the given values. I can very easily say that the efficiency of Carnot engine, efficiency is 1 by T2 by 1 minus T2 by T1, where T1 and T2 are the two temperatures and efficiency is given as eta. So if efficiency is given to be 0.4, I can write it to be 0.4 is equal to 1 minus temperature of sink divided by 500. So on solving this equation, you can very easily get the temperature of sink. And I'll write it to be, so 0.4 minus 1 with a negative sign will be equal to temperature of sink by 500. Hence, you can very easily calculate the temperature of sink, which comes out to be 300 Kelvin. So this is the first thing. Now using the same formula for the another efficiency, he says efficiency is to be 60%. So I'll say efficiency 0.6 will be equal to 1 minus 300 by temperature of source. That means now I have fixed that the sink has been given to us to be same. So I can say 0.6 minus 1 will be minus 300 by temperature of source. So I can very easily calculate the temperature of source to be 750 Kelvin. Let's see if we have any answer like this. Yes, so option number A is 750 Kelvin. So students, this was all about your chapter Thermodynamics, where we had tried to discuss the chapter and then we ended up doing the IIT-JEE questions. Students, here at Ask IITians, we provide you a very good opportunity where you can ask your doubts also if you have any doubt regarding any topic. For that, you first of all have to go on to www.askiitians.com website. If you open the page, you will find a topic as ask a question. So you can click at that link, ask a question. At the right hand side, you will get something where you will have to first of all select a category. The different categories that will be available, like it will be, you can have physics, you can have a question from maths or chemistry. So suppose I select a question from chemistry, then here you can also attach the image of the question if you have in account. Else you can type your question here and finally click over to get an answer. As soon as you type something over to get an answer, you can ask the question from your respective teacher. So hope this also helps you out and your query will be solved. So students, this was all about what I wanted to discuss with you people related to the chapter Thermodynamics. Just to recall you what we have done, I simply started up with the chapter Thermodynamics, where I told you what were the different kind of processes taking place. Before I told you something about processes, I had also discussed the basic terms which are involved in thermodynamics. Like what do we mean by system, surrounding, the boundary. Once we covered the basic definitions, we moved over to the different kind of processes. For example, the adiabatic processes, isothermal processes, isochoric processes. Also, we had a discussion of the different kinds of systems. We had seen different kinds of systems associated. For example, there were homogeneous systems and there were heterogeneous systems. So once we completed up with the discussion of the basic concepts of thermodynamics, we moved over to the different laws of thermodynamics. We had seen that 4 different laws of thermodynamics were given. The zeroth law, the first law, then we came over to the second law and the third law of thermodynamics. Once having the discussion of all the 3 laws and the 4th law of the thermodynamic also, then we moved finally over to the questions. Doing the questions, we realized that we need to do certain applicative parts. Then we moved over to the applications of thermodynamics, where I told you something about Carnot cycle, heat engine and bomb calorimeter. Finally, we had tried doing certain IIT-JEE previous year questions. So, now since I have the discussion of all the complete chapter of thermodynamics with you people, I suppose now you have got the confidence of doing the thermodynamic questions in the exam more nicely. So with this belief that you understood the chapter and you enjoyed the videos, I'll ask you to stay tuned for the further upcoming lectures from Ask IITians. Even for chemistry, maths and biology lectures, you can refer to our videos on the Ask IITians website. So I wish you all the best for your exams. Stay tuned and be happy.